Hey everyone, so here's lesson 8 in our Earth and Climate unit. We're focusing now on how our Earth is what we're going to call out of balance and how and why things aren't going quite well for us. So we're going to focus a little bit on the evidence for climate change in this lesson and why it's widely accepted that our climate is changing, and not only is it changing, but it's changing against typical patterns. There is no single piece of data, like there's no one kind of overarching piece of data that is telling us, yes, climate change is happening. Because of this kind of lack of single data, a lot of people have a hard time kind of accepting this idea. You know, they're going, well, show me the one thing that is pointing you towards climate change. The problem with that is that it just doesn't exist. But what we do as scientists is we aggregate lots of different observations, lots of different pieces of evidence. We put all of those together, and that kind of paints us a clearer picture, and that allows us to draw the conclusion that yes, the climate is changing, and not only is it changing, but it's changing against usual patterns, or against what we would predict would be the natural cycle of change. So what are these changes, right? What are these individual pieces of evidence that, when put together, lead us to climate change? The first one is the rising temperatures across the globe. So we have been keeping temperature data, measured data, for the past 200 years ago, starting in about the 1800s. So we don't have much before then, but like we spoke about in the last lesson, we are able to still draw conclusions about climate, even though we didn't have hard temperature data, for example. If you take a look at figure 2 on this page, the one on the left, it shows you the average global temperatures over the past just a little over 100 years or so. You can see for the first, let's say 50 to 60 years in that graph, everything looked relatively steady. And then if you're looking at 1940 and to today, now this textbook is it's a couple years old, so we don't have data into 2016, 2017, but there's a very clear pattern that the temperature is rising. If we look at the figure to the right of that, we can see in different pockets of the Earth how that is. And we should note, and this is for your notes here, you should note that warming is not even over the globe. Like, it's not 1 degree everywhere. You kind of see that more of the northern areas are experiencing a larger change in temperature compared to some of the southern areas or areas closer to the equator. And that's fine. That's, again, kind of something that is used against the idea of climate change. Well, some places aren't necessarily increasing in temperature, and that's true, right? If you're looking at the southern, these pockets between South America and Africa where there's white or even light blue, that is actually showing that it's getting colder. And that's why we don't use the term global warming anymore, because there are pockets of the globe that are not warming, but we're just talking about climate change and how things are drastically moving away from the mean or the average. If you look at Canada, Canada's average temperature increased by about 1 degree Celsius over the last 50 to 60 years or so. But you can look at other parts of Canada, up in the Yukon, for example, where it's typically much colder, and the temperature there has increased by about 2.5 degrees Celsius in some parts of the Yukon. So we can see that it's not constant, but it is happening. Now, another big question that a lot of people ask is, well, who cares, right? 1 degree Celsius is not a big deal. You can't even feel that difference. And you're right. 1 degree Celsius does not seem like a big deal until you remember that our planet is huge, right? So that's a 1 degree average over an incredibly large surface area. So that should put it into perspective. You should also kind of look at global averages before, they've been less than a degree change from year to year, half a degree, if that. So the fact that we are the 1 degree and plus area should be quite alarming for some people. Next up is now something that a lot of you guys are talking about in your reports or presentations, is the melting of the glaciers or ice sheets or sea ice, just the melting of ice in general and turning into water. And you should note that, sorry about that, average glacier sizes are decreasing across all of the kind of cold pockets in our on our planet. Glaciers are particularly important because they are sources of clean drinking water. Our glaciers provide us with about half of our population with drinking water. You can imagine that if these glaciers go away, that it's going to cause shortages in fresh water. So that's why glaciers are important for us. It's not just because it's a pocket of ice. If you take a look at ice sheets in Greenland and Antarctica, and then sea ice levels in the Arctic Sea, they are also disappearing. Just so that you can differentiate between the two terms, ice sheets are ice that is on land, and then when the ice that's on land melts, well, where does it go, right? It's got to go into the water because it's going to run off, and that's going to increase the sea level. Sea ice, to be just a little bit different, is ice that's floating on water. It's not that this is not as big of a concern, but it doesn't affect the sea levels as much. But what you should note is that ice is obviously floating on top of the water, so as it melts, it'll increase the volume of water. It's just that some parts of sea ice are also beneath the surface, so they're not seen. They don't affect the overall volume as much, but it's the sea ice that is floating on top that as it melts, it increases the volume of water available, and then of course that's going to cause issues. And that's the next kind of global phenomenon we're going to talk about, which is rising sea levels. Again, you need to think about the fact that there is a lot of water on our planet. It covers a huge amount of the surface area of our planet. So small increases in the sea level can have drastic effects, because that, a couple of meters of an increase is a huge volume of water for us. It can result in some low-lying regions to become flooded. There are some computer simulations that are expecting the southern tip of Florida to be covered in water in the not too distant future. So we talked about glaciers and ice sheets melting, and that leads to water running into the ocean. And that is one of the two ways, or one of the several ways, but one of the two that I want you to focus on, ways that sea level rises. So it's the glacier and ice sheet melting. The other point that I want you to note about rising sea levels is what we call thermal expansion. As the temperature of water changes, the density of water changes. Now, the mass will stay the same, so what's going to get changed is the volume. As the temperature goes up, as water is heated, it expands and it starts to take up more space. So you just got to be careful, or we should be careful with the fact that the increasing global temperatures, it's doing twofold to our rising sea levels, where the ice is melting, but then the water actually in the oceans and in the bodies of water is also increasing in volume just on its own. The last section here, we've got kind of 3 points. Changes in severe weather, precipitation, and ecosystems. And I hope you've kind of heard this before, that we are having more and more severe weather. If you were paying attention to Inconvenient Truth, you can hear Al Gore talk about the number of hurricanes that have kind of plagued the United States over the past few years. So in terms of weather, severe weather, we're having an increased frequency and intensity of severe weather events. So the increased frequency meaning they're happening more often, and the increased intensity meaning that when they do happen, they're worse than we would expect. If we're talking about hurricanes, for example, hurricanes are categorized from 1 to 5 depending on the wind speeds. The number of category 4 or 5 hurricanes, which is essentially kind of a death sentence for wherever that hurricane touches down, or typically has touched down by then. But if you get hit, or if a region gets hit with a category 4 or 5 hurricane, it's pretty much done. Those have doubled over the last 40 years. If we take a look at precipitation, so anything that falls from the sky, more heavy precipitation events have occurred in some areas, which would lead to higher water levels and then flooding, while other areas, such as California, as a more relevant example, are experiencing more droughts. So we're going on both ends of the spectrum here, right? More water in some areas that don't necessarily want it, and then significantly less water in some areas that might need it. Ecosystems are also changing. Plants and animals respond to changes in temperature and precipitation by flowering earlier and breeding earlier. So you might see an overpopulation of particular plants or animals that aren't necessarily supposed to be there. Also, undesirable insects and plants are migrating north because it's getting warmer. If you take a look at this handout, you'll see that there are a couple images on the last few pages. I'll let you go through them on your own if you want. They might be useful for your projects or presentations. But one, for example, is the West Nile activity in North America. Now, these mosquitoes have migrated from somewhere else. They don't typically thrive in North America because it's so cold up here. But they've managed to survive up here, and then mosquitoes multiply very quickly. So there are some plants and animals that typically don't like the cold that have made their way up here. So that's it for the notes. If you want to take a look at the rest of this handout, there's a whole bunch of pictures and graphs that might be useful for you depending on what your topic is. So take a look at them. The headers are good, so you can kind of Google what you might want to, what images or pictures you might want. There's some good graphs in there as well. So as always, let me know if you have any questions. And that's it for this lesson.